So hello and welcome back. So in this video we want to do another example of exponential functions. This is a simple one. So the question is, Derek sent a chain letter to his friends asking them to forward the letter to more friends. We had this in the beginning of this, I guess a few videos back. We had this as well. So the group of people who receive the email, the group of people who receive the email gains 9/10 of its size every 3 weeks and can be modeled by the function p, which depends on the amount of time t in weeks. Derek initially sent the letter to 40 people. Now write a function that models the group of people who receive the letter or receive the email t weeks since Derek initially sent the chain letter. So what you can do here, you can simply write the function as 9/10 would be, well, basically Derek initially sent the letter to 40 people. So this is the initial point of your function. So that means when t is equal to 0, your p of t, which is your function here, your p of t is equal to 40. That's where Derek starts. Basically started with 40 people. Now, and we know that the group of people who receive the email gains 9/10 of its size every 3 weeks. Gains 9/10 of its size every 3 weeks. So what does that mean? Gaining 9/10 of its size every 3 weeks. Gaining 9/10 of its size. So basically the group of people who receive the email gains 9/10 of its size every 3 weeks. So this basically has two parts. So first you have the gaining 9/10 of its size, and then it happens every 3 weeks. So that means that, for example, the group of people who receive the letter is basically 40 people. So you have 40 people, and this group of 40 people gains 9/10 of its size. Gaining 9/10 of its size means that you have 9/10 basically means 90%, or basically 9/10 is equal to 0.9, which is basically 90%. If it's gaining 9/10 of its size, it means it's being increased by 90%. So then you have to multiply this number by 1.90, so that you're increasing 40 by 90%. If you multiply 40 by only 0.9, you will have calculated only 90% of 40. But when you want to increase 40 by 90%, you multiply it by 1.90, because in increasing 40 by 90%, you have to add 90% of 40 to 40. So adding 90% of 40 to 40. So this is 40, and I'm adding 90% of 40 to 40. This is increasing it by 90%. So I can take a 40 out, and it becomes 1 plus 9/10 And I can simplify this by write this as 10 by 10 plus 9 by 10. So this becomes 40 into 19 by 10. Now 19 by 10 is 1.9. So 40 times 1.9. And that is basically what I've written here. 40 times 1.9 means increasing 40 by 90%. So this is the initial value of your function, and this is the amount by which this initial value is being increased, and that's nothing but gaining 90% of its size. And if I call this P of t, and if I put a t index here, if the variable put it here, then in week 1, then in week 0, basically in week 0, when t is equal to 0, then it is 1.9 raised to the 0th power, which is 1, so it becomes 40. So in week 0 you have no problem. In week 1, so P of 1 becomes 40 times 1.90 raised to the 1st power. So now in week 1, I have increased 40, the group of 40 people, by 90%. But that is not what we were basically told. We were told that the group of people gains 90% of its size every 3 weeks. So I have to do something else. I have to write this as P of t, and the initial value was basically right. It starts with 40. And then you multiply this by, of course, 90%, which is 1.90. But this has to be multiplied by the output of the function every 3 weeks. So instead of writing t here, I write it as t divided by 3. So now if I go week 0, here this becomes 0 divided by 3, which is 0, and then 1.9 raised to the 0th power is 1. So in week 0 you're fine. In week 2 you are multiplying 1.9 raised to the 1/3, and then that's multiplied by the output of the function. In week that was week 1. In week 2 you are multiplying 1.9 raised to the 2/3 power, and then that is multiplied by this 40. In week 3 you are multiplying 1.9 raised to the 3/3 power. 3/3 is 1. So basically you're multiplying 1.9 by 40, and that is nothing but increasing 40 by 90%, and that's basically what we needed. So if you did not understand this, we can do it another way. So we said that we had a function, we had a function t which was in weeks, and P of t is the number of people who received the email, the chain email. And the Derek starts with sending the letter, basically sends the letter initially to 40 people. Now to 40 people, after 3 weeks, it's going to be after 3 weeks, so every 3 weeks, the size is 9/10. I'm sorry, the size, the number of people who are receiving the letter is increased by 90% or gaining 9/10 of its size every 3 weeks. So what that means is that in week 1, after 1 week, you are okay, so basically I think we could explain it this way using the table. So you don't know, basically based on this explanation that tells you that gaining 9/10 of its size every 3 weeks, you don't know what happens when you are in week 1. So what you could do to still be able to use the table, you could go to week 1, week 2, and week 3. So in week 3, you don't know what happens here, you don't know what happens here, but you know that your output excuse me, you know that your output here is going to be 40 times. Now it's gaining 90% of this output. So 90%, gaining 90% of this output would be equal to multiplying by 1.09 or 90%. No, I'm sorry, 1.90. So, and the same thing basically happens here as well. You go week 4 and week 5. Again, you don't know what happens here. But in week 6, again, 3 weeks after week 3, this output is going to gain 90% of its weight. So again, you have 40 times 1.90, and this was this output. Again, you have to multiply it by 1.90. And the same thing keeps happening and over and over again. So now, using this information that you have, you can write your function. So your function basically is of the form p of t is equal to a, if we can do that, a times r raised to the power t. And of course, well, your p of t is equal to a, which is this point here, because this output happens when your input is equal to 0. So this becomes your initial value of the function. So it's simply 40 times. R is your common ratio here between these two outputs, but you need to understand that this output happens after 1, 2, and 3 intervals of your input variable. So you can still write your 1.90 here, but because it happens after 1, 2, so basically 1 here, 2 here, so here happens 1 plus 1 plus 1 is after 3 intervals of your input. So then, of course, here again it has to happen after 3 intervals of your input, because 1.90 has been multiplied by your output by this 40. But this hasn't simply happened here. This happened after 3 intervals. So here again it has to happen after 3 intervals, and that means that you, instead of simply writing t, you have to make changes to your t so that it happens after 3 intervals as it has happened here. And t divided by 3 means that it happens after 3 intervals. So t is, for example, 0, and then 1, and then 2, and then 3. So that then it becomes 3/3. After 3 intervals, it becomes 3/3. And 3/3 basically means 1. So then it is, after 3 intervals, your index becomes 1, and then 1 factor of 1.90 is multiplied by your 40. Now after it is week 3, then you go to week 4 and 5 and 6. Again, after 3 intervals, your t is equal to 6 here. So 6 divided by 3 is equal to 2. So 1.90 raised to the second power, because 6 divided by 3 is equal to 2. Raised to the second power means that you are multiplying, in effect, you're multiplying 2 factors of 1.90 by your 40. And that's basically what happens here. 40 times 1.90 times 1.90, 2 factors here. And so that's how you can write the equation for this function. So thank you very much. I'll see you in the next video.